Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access the course page on my personal website arif.me. You can click the appropriate link under the lecture resource column to view it in NB Viewer and run it online in Binder. Well, the other way is to download the notebook file from the course GitHub account RFPUCIT. And all notebooks for this course are housed in the public data science repository. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888. And here is the notebook for lecture 3.3 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. Well, my dear students, in the last two sessions, this is the third session on NumPy. In the last two sessions, we learned different ways to create NumPy arrays. And I've also seen a practical comparison between the Python list, Python built-in arrays, and the NumPy arrays. Well, in today's session, we will see how we can perform different arithmetic operations like add, subtract, multiply, divide, and modulus with elements of a NumPy 1D and 2D array. And we will perform these operations with scalar values as well as among the elements of two n-dimensional arrays. We will also see how we can perform different element-wise mathematical operations like square root, cube root, logarithms, ceiling and floor functions, cumulative sum on both the 1D and 2D arrays. The power of the NumPy arrays will become evident to you all when we will see the use of different aggregate functions like min, max, sum, mean, average, median, percentile, variance, and standard deviation on both 1D and 2D or maybe 3D arrays. And finally, we will do the comparison and maybe the searching operations. And these matrices or linear algebra operations will be dealt in a separate session, inshallah. And the beauty of all these operations that we will be performing is that we will not write a single loop to perform any of these tasks. So here is the agenda of today's notebook, which I have already discussed. So let's start playing. So if you have not installed it, do install it on your system. And right now the version of NumPy running on my machine is 1.19.5. Okay, first of all, the scalar math on 1D arrays. My dear students, I am creating a NumPy array using the randint method. Size 4 elements ranging from 1 to 9. So this is going to create an array having random values 1, 2, 9, and 1. And here are some basic arithmetic operations that you can perform on these arrays using the scalar values, the addition, subtraction, multiplication, division, and modulus. You can use these operators as well as you can use the add, subtract, multiply, divide, and the mod method. And of course, remember, you will get a new object, and this is what I have proved over here by printing the ID of the new array after this operation. And the IDs, as you can see, are of course different. So these operations return a new array. Great. So similarly, the same operations can be performed on the 2D arrays, and over here for an example, I have just created a 2D array, a 2 by 2 matrix having random integers from 1 to 9. I have used the randint method, and over here I have used these basic scalar operations. So this is the original matrix, and let me run it again. so that it should have some real random values. Okay, this is okay. So I have added 2. 2 has been added to every element of this original matrix. Subtracted 2. 2 has been subtracted from every element of this matrix. So this is a element by element operation. And you see the beauty? No loop is required. Okay, let's move ahead. Talk some arithmetic operations among the elements of two 1D arrays. This time we have two one-dimensional arrays. I have kept the size of the array small, just an element of size 4, another element, and another array of size 4, having random values from 1 to 9. So this is the first array 6153. This is the second array 5829, and this time I have performed the arithmetic among the elements of these two arrays, and you can see the results over here. Remember, after the divide operation, we always get the result as a float. I hope this makes sense to you all. And remember, for the time being, I am assuming that both the arrays are of same size. We will talk about this in detail when we will be discussing broadcasting in the NumPy arrays. That what will happen if the size of the two NumPy arrays is different and we perform these operations on them. For the time being, let's keep the things simple. So I think this makes sense. Let's see these operations on 2D arrays now. So over here I have created once again a 2 by 2 matrix so that you can understand the results as well. So this is matrix 1 containing these 4 values. This is matrix 2 containing these 4 values. And I performed these addition, subtraction, multiplication and division and modulus operation on the elements of these two matrices. Please do see that this one has been added with this one, and we have got a 2 over here. And similarly, the rest of the operations can easily be mapped. Okay, so some more mathematical operations. First on 1D arrays, like the square root, logarithms, cube roots, ceiling, floor, cumulative sum, and so on. So we can perform all these operations on these values. And this time I have used the rand method. I've used the rand method to generate an array of 5 elements from 0 to 9 floating point values. This is the array that I have created. This is the original array, and these are the functions which have been performed on each element, and we have got the answer. So this is the array and this is the square of that value, and this is the original value and this is the floor of that value, 6 dot, and this is the value and this is the seal of that value. And similarly, this is NaN is a method that is used to identify NaN values, if any, in the input array. And since this array do not have any NaN value, so we have got all false over here. My dear students, do spend some time, make changes and run it again and again. Since I have used the rand method, so you get different values. Build up your concepts, because this is what we are going to do in on large data sets whenever we will be analyzing the real-time data sets and performing analytics on them. Okay, the way we can perform these mathematical operations on 1D arrays, we can perform them on 2D arrays as well. So over here I have created a 2D array. For simplicity, I have generated the integer matrix this time using the rand int method, a 2 by 2 matrix. So over here I have computed the square. You see, this is 8 and this is 64. Then I have done the square root, the log of base 2. You can take the natural log and log base 10 as well. Is NaN, seal, floor, all the functions can be applied over here, which we have applied in the case of 1D NumPy array. Okay. So next come the aggregate functions. My dear students, this is the real part. A lot of aggregate functions are there. This min, max, sum, and product, these are very simple. I have just generated a an array this time of 5 elements from 1 to 9, and this is the minimum of this array, this is the maximum of this array 9, this is the sum 5 plus 1 plus 2 plus 4 plus 9, and this is the product of all the elements. So you get a single value after applying this function on all the elements of the array. Hope this makes sense. Excuse me. Let's move ahead. Okay, let's try to understand the two more functions. One is the mean and the other is average. Okay, so for this I have generated once again integer array of 5 elements containing right now 6, 6, 3, 1, 5. So I have computed the mean. Right, my dear students, arithmetic mean is the sum of the elements along any axis in case of ND array divided by the total number of elements. So 6 plus 6 plus 3 plus 1 plus 5 divided by 5 is of course 4.2. This is the mean. So we have another function that is average. Average is normally used whenever you want to have a weighted average. In case if you do not want to have a weighted average, you can just pass the array to this average method. It will just compute the mean. And you see, it has computed the mean. The real power of this average method comes when you want to compute the weighted average. Let's suppose that you have this array 1, 2, 3, 4. And let's suppose you have associated weights with each element of this array. And hypothetically, I have taken the weights as 4, 3, 2, and 1. So what weighted average mean is that you multiply the corresponding elements, the element, for example, 1, and the weight of that element, that is 4, plus the second element, 2, the weight of that element, that is 3, and so on. And you sum them up and you divide them with of course, the sum of the elements inside the array. So this way you get the weighted average. So for the weighted average, you need to do is you pass two arguments to this average function. The first is of course the array, and the other is another array that contains the weight of each element of this array. So we have got the answer as 2. So let me run it again. I think I have not randomized things, so I will always get the same result for this. Fine. 1 into 4 plus 2 into 3 plus 3 into 2 plus 4 into 1 divided by 1 plus 2 plus 3 plus 4. I hope I have made your concept clear as far as the difference between the mean and the average is concerned. So whenever you have to compute the weighted average, you go for this average method instead of the mean method. Let's move ahead. Okay, we do have the median, we have the percentile, variance, and standard deviation. Inshallah ta'ala, we will talk in detail about these in our statistics and probability module of this course. However, for the time being, just remember that median, as we all know, is the value separating the higher half and the lower half of the data. Let me run it and let me show you that this is the array. This time I have generated a larger array of around 10 elements having elements from 1 to 99. So this is the median. 42.5 is the median. So you see 1, 2, 3, 4, and 5. So 5 elements are below 42.5 and the rest are above it. So this is the median. Fine. Percentile. My dear students, this percentile is the value below which a given percentage of observations in a group of observation fall. Suppose if you find the percentile of this array with a value of 50, so it will tell you how many values fall below 50 and how many values fall above 50. So 50% rather. So 50th percentile, which I am calculating right now, this is the score at or below which 50% of the scores in this distribution falls. So let me run it again and see the different values. Okay, so now we have 64.5. So 64.5 is the value at or below which 50% of these scores or of this distribution lies. And if I find the 0th percentile, of course that will give me the smallest value, and the smallest value is 24 in this array. And if I find the 100th percentile, so this will give me the largest value, and that is 99. Similarly, variance actually measures the average degree to which each of these points differs from the mean. And how we calculate variance is that we calculate the mean, we calculate the difference of every element from the mean, square it, and that is the variance. And if we take the square root of that, that becomes the standard deviation. So the applications of this variance and standard deviation, we will of course discuss in detail in our statistics and probability module of this course, inshallah. Okay, so this we have applied all the aggregate functions on 1D arrays. We can always apply them on 2D arrays. However, whenever you will be applying them on 2D arrays, you need to keep one point in mind, that you need to mention the axis. Excuse me. So if this is a 2D matrix having let's suppose 3 rows and 3 columns, so if I want to compute the sum on the 0th axis, remember we have talked in the previous session that axis 0 is the column. So 8 plus 4 plus 3 is 15. So this is axis 0. 5 plus 8 plus 6 is 19. This is axis 0. 2 plus 1 plus 6 is 9. This is axis 0. And axis 1 represents the rows, moved from left to right. So 8 plus 5 plus 2 is 15 again. 4, 8, 1 makes 13. So I hope this makes sense. Let me run it again. Okay, so once again, please remember, whenever you are applying aggregate functions on an ND array or a 2D array, you need to provide a second argument, and that is the axis argument. Axis 0 is the vertical axis and axis 1 is the horizontal axis. Axis 0 moves from top to bottom and axis 1 moves from left to right. Okay, so if this axis is clear, you can similarly apply the minimum method as well on a 2D matrix. You can apply the mean on the 2D matrix, and of course you can apply the median as well on the 2D matrix. My dear students, please do practice calculating the percentile, variance and standard deviation as well along different axes of a 2D array. Let me move ahead. Okay, so now comparing, my dear students, you can easily compare the two NumPy arrays element by element. Let's suppose that I have an array 6946 and another array 5285. I can compare these two elements 6 and 5. 9 and 2, and these all are the comparison operators which are available to you. Equal to, not equal to, greater than, equal to, less than and less than equal to. You can apply them using these operators, or you can use these methods as well. And of course the resulting value is another array of course the same size, containing either false or true. Hope this makes sense. Okay, the way we can compare the NumPy 1D arrays, we can compare NumPy 2D arrays as well. So here is a sample code that describes the concept. So we have two simple matrices, a 2 by 2 matrix and another 2 by 2 matrix. And over here I am performing the equality check. You can see 8, 9 false, 4, 7 false, and they all are false. Okay. And for not equal, they all are true. For greater, they are false. And okay, so this is piece of cake, I think. But do make time to run these codes so that you should have a fair understanding of how you can compare the elements of NumPy arrays. And finally, you can perform searching using the where method of the NumPy module. This where method is used to search NumPy arrays to find out the index values of any of the element within that array based on this condition. If this condition evaluates to true, that index will be returned. Let me show you this with an example. Okay. Let's suppose we have an array 1, 2, 3, 4, 5, 4, 4, 9, 2, 3 and 8. And I just want to search from this array the element whose value is 4. So this will return all those indices where this condition evaluates to true. 0, 1, 2, 3. At 3 this evaluates to true. 4, 5 this evaluates to true. And at 6 this evaluates to true. Let me change this to let's suppose 8. So for 8 it evaluates to true only at this index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Of course 10. Fine. And remember this is the result is a tuple. So we have a tuple as a result and a tuple of actually 1D array having just one element. If I put a 4 over here, remember I have got a tuple having a 1D array of 3 elements, of 3 indices. Let's do it on this, another example. So over here I just want to search for zeros. So great. At index 1 and at index 6 we have a 0. Let me do another example. So let me search all those elements which are even numbers. So 1 is even, at index 1 we have an even value, at index 3 we have an even value, at index 5 and at index 7 we have an even value. Great. So this is a simple usage. Another optional parameters are x and y. So this x and y can be used to yield the value x if this condition is true and otherwise y. Let's see the example. Okay, let me run it. So when this condition evaluates to true, this value will be assigned, otherwise this value will be assigned. Or so this is even, so we have a true over here. This is even, so we have a true over here. So let me say something else. Okay, let's move ahead and talk about this where method for the 2D arrays as well. It will not be difficult much, I think. So over here I have a 2D array, an array having 4 rows and 3 columns, and I have searched the element 4 in it. So 4 is there at index 0th row, first row, 0th column, 1, 0. So we have a 1 over here and a 0 over here. Note that this time this is also again a tuple, but this time this tuple has the 2 values. This tuple has 2 tuples inside it. So you just join these values 1, 0, 1, 2 and 2, 2. So these are the 3 indices where this match exists. This 4 exists at index 1, 0, at index 1, 2 and at index 2, 0. I hope this makes sense. Let's see another example. Over here we are searching for zeros. So zeros exist at index 0, 2, at 1, 2 and at 3, 1. So note the output. Remember, a tuple of 1D array having 2 tuples. In case of 3D array, there will be 3 tuples in the output. Okay, so let's see this example as well. So same old example for even numbers. Makes sense? And this is the example which is returning some values, having the x and y arguments as well to this where. My dear students, I hope this is making sense to you all. Okay, so fine. So that is all, my dear students, for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. I hope today's session was informative for you all, and if you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.